Assalamu alaikum, my dear student. How are you? I hope all of you are fine by the grace of Almighty Allah subhanahu wa ta'ala in this time. I am Golam Mortuja and I am your physics teacher. Today I will discuss with you some MCQ. Dear student, here you can see that this is our first question. Okay? And the question is, what is the coefficient of volume expansion of copper? Okay, we know that the coefficient of linear expansion of copper alpha equals to 16.7 into 10 to the power minus 6 per Kelvin. Okay, and we know that the relation between the coefficient of linear expansion and the coefficient of volume expansion. Okay, we know that the coefficient of volume expansion gamma equals to 3 alpha. That means if we multiply the coefficient of linear expansion with 3, then we will get the coefficient of volume expansion. Okay, so 3 into 16.7 into 10 to the power minus 6 equals to 50.1 into 10 to the power minus 6 per Kelvin. Okay, so the coefficient of volume expansion of copper gamma equals to 50.1 into 10 to the power minus 6 per Kelvin. Okay, and here you can see that this is our second question, which is the triple point of water. Do you know what is the triple point of water? The triple point of water is 0 degrees Celsius or 273 Kelvin. That means at this temperature, ice, water and water vapor, all the three states will be exist. Okay, and that is the triple point of water. Dear student, here you can see that this is our number 3 question. Okay, and the question is, length at a steel wire is 100 meter and its temperature is 20 degrees Celsius. If wire's temperature is 50 degrees Celsius, then the length becomes 100.033 meters. That means when the temperature is increased, the length is increased. Okay, so that what is the coefficient of linear expansion of steel? Okay, so at first we have to write the given value. Okay, here you can see that what is the given value? Length of wire, that means the initial length of this wire L1 equals to 100 meter. Okay, and the final length L2 equals to 100.033 meter. Okay, and here you can see that the initial temperature T1 equals to 20 degrees Celsius. If we add 273 with this degree Celsius, then it will convert from degree Celsius scale to Kelvin scale. Okay, so 20 plus 273 equals to 293 Kelvin, and the final temperature here you can see that 50 degrees Celsius. That means 50 degrees Celsius. So we should add 273 with 50. 273. Then the value will be 323 Kelvin. Okay, and now we have to find out the coefficient of linear expansion, and we know that the formula of linear expansion equals to alpha equals to L2 minus L1 divided by L1 into T2 minus T1. Okay, then if we put all of this value in this equation, 100.033 minus 100, then 100, L1 equals to 100. Then T2 equals to 323 and T1 equals to 293. 293. If we put all of this value in my calculator, then I will get 11 into 10 to the power minus 6 per Kelvin. Okay, so here you can see that the coefficient of linear expansion of steel is 11 into 10 to the power minus 6 per Kelvin, and this is our number 4 question. Here you can see that the question is 1 calorie equals to what joule, and we know that 1 calorie equals to 4.2 joule. Okay, and you have to memorize this value. So dear student, this is our number 5 question. Okay, and here you can see that what is the normal temperature of human body in Kelvin scale. Dear student, do you know what is the normal temperature in a human body in degree Celsius scale? After that, you have to convert degree Celsius to Kelvin. Okay, we know that normally the normal temperature of a human body in degree Celsius scale is 36.89 degree Celsius. Okay, and after that, if we add 273 with that value, then it will be converted from degree Celsius scale to Kelvin scale. Okay, so 36.89 plus 273, then it will be converted from Celsius scale to Kelvin, and the value will be 309.89 Kelvin. Okay, my dear student, 309.89 Kelvin is the normal temperature of a human body. And the number 6 question is, what is the relation between coefficient of linear expansion alpha and the coefficient of volume expansion gamma? The coefficient of linear expansion, which is expressed by alpha, the coefficient of area expansion, which is expressed by beta, and the coefficient of volume expansion, which is expressed by gamma. Okay, and we know there is a relation between the coefficient of linear expansion and the coefficient of area expansion and the coefficient of volume expansion, and the relation is that 2 gamma equals to 3 beta equals to 6 alpha. Okay, that is the relation among this 3 coefficient. Okay, but now I have to find out the relation between coefficient of linear expansion and the coefficient of volume expansion. Okay, so I have to took this 2 value. Okay, if I take this 2 value, then it will be 2 gamma equals to 6 alpha. Okay, so gamma equals to 3 alpha, and that is the relation between the coefficient of volume expansion and the coefficient of linear expansion. This is our number 7 question, and question is, how much heat is required to increase the temperature of 1 Kelvin of 10 kg water? Okay, so at first I have to write the given value. Okay, here you can see that the given value, temperature, increased temperature del T or T2 minus T1 equals to 1 Kelvin. Okay, and the mass of the water M equals to 10 gram. If we divided this 10 gram by 1000, then it will be converted from gram to kg. okay, and the answer will be 0.01 kg, okay. And we know that the specific heat of water S equals to 4200 joule per kg per Kelvin, okay. That is the value of specific heat of water, and you have to memorize this value, okay. And we know that the heat formula Q equals to M S del T. So if I put all of this value in this equation, then it will look like that: 0.01 into specific heat of water equals to 4200 into the increased temperature equals to 1. So the answer will be 42 joule, okay. So 42 joule heat is required to increase the temperature of 10 gram water of 1 Kelvin. Number 8 question is, at which temperature the density of water is highest? Do you know at which temperature the density of water is highest? Normally, for the specific mass of a specific object, if you increase the temperature, the volume will be increased, and that's why the density of the object will be decreased, because the relation between density and the volume is inversely proportional. But that is different for water. That means if we increase the temperature, and if the temperature is 4 degrees Celsius, then the density of water will be highest, okay. That means at 4 degrees Celsius temperature, the density of water will be highest. Number 9 question is, at which medium the speed of sound is highest? Do you know at which medium the speed of sound is highest? At air medium, the speed of sound is lowest. After that, the liquid medium, the speed of sound, air medium, and for the solid medium, the speed of sound is highest than air medium and liquid medium. So, the speed of sound is highest at solid medium. Solid. Okay. Dear student, here you can see that this is number 10 question, and the question is, time period of a sound wave is 5.8 into 10 to the power minus 4 seconds, and the velocity of sound is 330 meter per second. What is the wavelength of the sound? Okay, that means at first I have to write the given value. Here you can see that the given value at time period is denoted by T, okay. T equals to 5.8 into 10 to the power minus 4 seconds, and the velocity is denoted by V equals to 330 meter per second, okay. And we know that now what is the wavelength of the sound? We know that there is a relation between velocity, wavelength, and the frequency, okay. We know that V equals to F lambda, okay. And we know that here you can see that the given value is time period, and we know the another relation between the time period and the frequency, okay. Because here we don't know directly what is the frequency of this sound, okay. And we know that frequency equals to 1 by time period, okay. So if I put the frequencies equation at that equation, then it will be look like that: 1 by T lambda V, okay. Now lambda equals to then Vt, okay. So if I put the velocity and the time period in that equation, so 330 into 5.8 into 10 to the power minus 4. Then the answer will be lambda equals to 0.1914 meter. Dear student, I hope you understand how can we find the wavelength by using the time period and the velocity. The number 11 question is, what is the angle between the wave particle in the direction of vibration and the direction of wave flow in longitudinal wave? Here, if I draw a wave, here you can see that the wave particle in the direction of vibration here, and the direction of wave flow, that means that direction. Okay, that means these two directions are equal, so that the angle between these two directions will be 0 degree. Okay, so I hope you understand why in a longitudinal wave the angle between the wave particle in the direction of vibration and the direction of wave flow is 0 degree. Dear student, number 12 question is, which of the following can be reduced by increasing the frequency of a sound by a certain medium? That means in a certain medium, if you increase the frequency of a sound, then what will be decrease? Okay, we know that the relation between time period and frequency is T equals to 1 by F, where T is time period and F is frequency. And here you can see that the relation between time period and frequency is inversely proportional. That means if the frequency is increased, then the time period will be decreased. Okay, so I hope you understand. If I increase the frequency, what will be decrease? Number 13 question is, what is the distance between the source and the reflector if the velocity of sound in air is 340 meter per second and the time period of echo is 1.5 second? So here you can see that the time of echo is denoted by small t, which is 1.5 second, and the velocity of sound v equals to 340 meter per second. Okay, and if we want to find out the distance between source and the reflector, then for echo we have to use d equals to vt by 2. Okay, where v equals to 340, t equals to 1.5 and 2. So we will get 255 meter. Okay, so the distance between the source and the reflector, d, will be 255 meter. Number 14 question is, if the intensity of sound is denoted by I and the amplitude of wave is denoted by A, what is the relation between intensity and amplitude of a wave? Okay, we know that the relation between intensity and amplitude is, if the amplitude of a sound is increased, also the intensity of a sound will be increased. Follow the figure and give the question number 15 and 16. That means here you can see that this is a wave. Okay, and here you can see that the number 15 question is, what is the wavelength of this wave? Okay, look at the figure, and here you can see that a full wave and 1/4 of a full wave total equal to 5 centimeter. That means a full wave plus 1/4 of a full wave. Total will be equal to 5. Okay, so if we add these two values, it will be 4 lambda plus lambda by 4 equals to 5, or 5 lambda equals to 20, or lambda equals to 4 centimeter. Okay, or we can say that lambda equals to 0.04 meter. Okay, so I hope you understand how can we find a full wavelength from this given value. Okay, number 16 question is, what is the frequency of the wave? That means, what is the frequency of this wave? And here we have the value of lambda, that means the value of a full wavelength, lambda equals to 0.04 meter, which I have already got from the question number 15. And here you can see that no velocity is given here, but we have to assume the velocity of sound at here medium v equals to 330 meter per second. Okay, now we have to find the frequency, and we know the relation between frequency, wavelength and the velocity, and it will be v equals to f lambda, or f equals to v by lambda. V equals to 330 divided by 0.04 equals to, answer will be 8250 hertz. Okay, so I hope you can understand how can we find the frequency of a sound by the given value of wavelength and the velocity. Number 17 question is, what is the velocity of sound in a vacuum at 20 degrees Celsius temperature? Okay, so this is very interesting question. Can you guess what will be the answer? Okay, let me explain it. In vacuum space, there is no medium to carry the sound from one place to another place. Okay, that's why at the vacuum space, the sound will not go from one place to another place. 20 degrees Celsius temperature at the vacuum space, the speed of sound or the velocity of sound will be 0 meter per second. Number 18 question. What is used for more developed type of periscope in submarine? Do you know what is used in submarine periscope? Okay, prism is used for more developed type of periscope in submarine. Number 19 question. Here you can see that, what is the value of linear magnification when one man stood in front in a mirror and saw him twice length image in this mirror? So at the time, what will be the linear magnification? Okay, the formula of linear magnification, m equals to L prime by L, where L prime is the length of image and L is the length of object. And here you can see that if we assume that the length of this man is x meter, and here you can see that the image is twice length. Okay, so L prime equals to twice x meter. Okay, so if I put this two value in this equation, we'll get 2x by x. So the linear magnification will be m equals to 2. I hope you understand how can we find the linear magnification. Dear student, now number 20 question. And here you can see that the question is, the length of an object and the magnification of a convex mirror are respectively 0.5 meter and 0.2. Okay, that means 0.5 meter the length of an object and 0.2 is the magnification. And here what will be the length of the image? Okay, here the given values are length equals to 0.5 meter of the object and the magnification is 0.2. Okay, so we know that the magnification m equals to L prime by L. So L prime equals to m into L. M is the magnification, L is the length of object. So if we put the value of magnification, m equals to 0.2 and the length of the object is 0.5, then we will get the answer 0.1. So the length of the image L prime equals to 0.1 meter is the answer. Okay, number 21 question is, which mirror is used on the side of hilly roads? I think you know that hilly roads are very zigzag most of the time, and that's why there is a possibilities to occur any kinds of accident. To avoid that kind of accident, plain mirror is used at the hilly road. Number 22 question is, what is the reflected angle in this figure? That means we have to find the reflected angle NOB. Okay, but we know that the law of reflection is the incident angle AON and the reflected angle NOB will be equal. That means the angle of AON and the angle of BON will be equal. Okay, so at first I have to find out the incident angle. Here you can see that this 30-degree angle is not the incident angle, because if we want to measure the incident angle, we have to consider the normal. Okay, that means respect to the normal, we have to find the incident angle. Here you can see that MON, this angle is 90 degree and this angle we can divide by 2. That means angle of MOA plus angle of AON equals to angle of MON. So angle of AON equals to angle of MON minus angle of MOA, where the angle of MON equals to 90 degree minus MOA. This angle is here 30 degree. Okay, so we will get 60 degree. That means the angle of AON, that means the incident angle is 60 degree, and according to the law of reflection, the reflected ray will be also 60 degree. I hope you understand how can you find the reflected angle from this figure. Okay, number 23 question, which light has the lowest wavelength? Do you know which light has the lowest wavelength? Okay, violet light has the lowest wavelength. Okay, dear student, I hope you have enjoyed the class and you have learned all of this MCQ which I have discussed with you, and inshallah see you again. Assalamu alaikum my dear student.